All right, so this lesson is going to seem like a big shift in gears from the previous lessons because we've been dealing a lot with equations that have exponential growth or decay, and sometimes interest is being compounded, and maybe there's a half-life or it's doubling, and maybe it's compounded continuously, right? We've had a lot of word problems. But what we're going to start to do is take those word problems and begin graphing them and seeing what they look like when you model them and we plot them on the XY plane. So before we start graphing those word problems and those types of equations that we've been dealing with, let's start graphing just basic exponential functions. So in this lesson, what you're going to be able to do is graph the inverse of an exponential function using a table of points, and you're going to be able to approximate the values of those inverse functions just by graphing them. So we might need a little refresher here on what an inverse function is, but we'll get there as soon as we get to the graphing stage. So A just says to graph the following function, and you've got f of x. And all you know about it is that it's an exponential function. You can tell because x is in the exponent. So we're going to have to graph it on this grid we've got here. So let's turn it into a coordinate plane. All right, we've got an x-axis, we've got a y-axis, and in order to graph any function we've never seen before, all we need is a table. So we're going to say we've got x values and we've got f of x values, or in some cases y values. And what we want to do is we just want to throw this equation into some sort of calculator, and we'll keep calculating these values. And there are faster ways to do this, but let's evaluate it just the way we know how to do it right now. Let's say if I throw in a -2. Well, then I'm going to have 3 to the -2 power plus 1. That's going to be the same as 1 over 3 squared plus 1, which is going to be 10/9. So we will have the point -2, positive 10/9. So that's somewhere around, let's see, -1, -2, positive 10/9 is going to be just above a 1 there. Okay? What if we plot the point -1? Well, then we're going to have 3 to the -1st power. We'll add 1. 3 to the -1st is the same as 1 over 3. And we add 1 to that, and we'll end up with 4/3. And I'm getting these fractions by just adding fractions. You would need a common denominator here, right? So 1 would be the same as 3/3, and when you add 1/3 plus 3/3, you get 4/3. So this is just adding fractions very quickly. So then I have the point -1, positive 4/3. So -1 is here. Positive 4/3 is going to be a 1.25, a little bit higher up. Okay, what if I had a 0? Well, then I'd have 3 to the 0 power plus 1, which is the same as 1 plus 1, which is 2. So that's this point here. And we can just start plotting these points pretty quickly. We're going to get 3 to the 1st plus 1, that's a 4. So we have a 1, 4. We're going to get 3 squared plus 1, that's going to be 10. So we have the point 2, 1, 2, 3, 4, 5, 6, 7, 10. And now we have enough points to connect all these and say we've got some sort of function here that we are modeling. One thing that we know about exponential functions is that eventually they have some sort of asymptote. And right here, the asymptote is at y equals 1. We'll never cross that line y equals 1. It's just going to continue to get closer and closer and closer to y equals 1. So our function is going to continue to go to the left and continue to get really close to positive 1, but never actually reach it. And it will always continue upwards and positively in the x direction, and is not limited in either of those directions. All right, so there's our function. Then B says to graph its inverse as well. It might have been a while since we talked about inverse functions, but in order to graph the inverse of a function, there's really only one thing we need to do. It's very, very simple. The only thing you need to do to graph an inverse function is take each of the points in your initial function and flip them. So the first point in our inverse function is going to be the point 10/9, -2. And the second point in our inverse function is going to be the point 4/3, -1. And then we'll have the point 2, 0, and the point 4, 1, and the point 10, 2. So all we've done is taken each of these points, flipped them around, and now they are points in our inverse function. So I can plot them now. I have the point 10/9, -2, so that's going to be just a little over 1 to the right and down 2, so I'll have a point right here. I'll have the point 4/3, -1. I'll have the point 2, 0, 4, 1, and 10, 2. 2, 3, 4, 5, 6, 7, 8, 10, 2. Trying to make sure that it's perfect. There we go. All right, and now that we have all of those points, usually we say that if you got 5 points, you've got enough to graph it. So I've plotted 5 points, and now I'm going to connect those points. I know that it's an exponential function, and this time the asymptote is going to be x equals 1. Notice that it's going to approach that line x equals 1, but never actually reach it, same as it does in the y direction with our regular function. All right, so we've graphed both of them. And then the last question here is just asking, do you remember what the definition is of an inverse function? So an inverse function, and we know you can just flip the points, but an inverse function really is a function that's been reflected, and I'll use green here, over this line. This is the line y equals x. So if you take a function like this f of x, the red function here, and you reflect it over this line, you will get our blue function, or the inverse function. And this is something we talked about first couple weeks of school. We did a lot involving inverse functions, but we never did it with exponentials. What's going to happen when we get back from break is we're going to be defining these exponential functions, or these inverse functions. They have their own specific name, and we're going to be playing around with them a little bit. So the definition of an inverse function is just the reflection of a function over the line y equals x. And in this case, on our graph, it's in green right here, but you don't have to graph it in green, obviously. So on the back, you're going to have a couple of exponential functions you have to graph, and you're also going to have to graph their inverses. And then at the bottom, you're going to have to approximate the values of some of those inverse functions. So you're just going to be using the graph to try to figure out what is f inverse of 3 or g inverse of 5. So you guys should be able to do that. Hopefully, this isn't something that's totally mind-blowing. You're just graphing, just plotting points. It's just a new type of function. All right? So good luck, guys, and I will see you when you get back from break.